Hi, in this video I'm going to show you how to check whether the data follows normal distribution or not. This is also known as checking for normality. Now, the normal distribution assumption is essential in some statistical tests. For example, in one sample t-test or two sample t-test or ANOVA, we assume the data follows normal distribution. Now, how to check whether your data follows normal distribution or not for conducting some particular hypothesis testing, I'm going to demonstrate that on the job. Suppose if you want to conduct one sample t-test on this particular data. For that, first of all, you have to ensure the data is following normal distribution or not. To do so, or to check, go to Analyze, go to Distribution, and then drag and drop the variable into this particular role, which is y comma columns, and click on OK. You will get this type of output. Now go to this inverted right triangle, go to continuous fit and select fit normal. So idea here is, first of all, I will fit a normal distribution on the data, and then I'm going to check if it is a good fit or not. Now after you click on that, you will see this type of output. Now at the bottom, one short fitted normal distribution report will be appended. Again, click on this inverted right triangle here and then select goodness of fit. So as you can see, it says it shows or hides a report that contains a goodness of fit for the specified fitted distribution. You click on it. You will see p-value and some test statistic, Shapiro, Wilk, Anderson, Darling. So basically both are the hypothesis tests to check whether the data follows our normal distribution or not. In both the tests, the null hypothesis is that the data follows normal distribution or the data is from the normal distribution. The alternate hypothesis is the data does not follow normal distribution or the data is not from the normal distribution. And as we know, if the p-value is low, null must go. So suppose if my level of significance is 0.05, I just need to compare the p-value obtained by the tests which are given here. Now, as per the literature, if your data size is less than 2000, if the number of data points in your data are less than 2000, then you look at the p-value provided by the Shapiro-Wilk test. So as per the Shapiro-Wilk test, the p-value is 0.1734, which is higher than the level of significance. So we fail to reject the null hypothesis, which is the data is from the normal distribution. Hence, the data follows normal distribution and we can go ahead and conduct one sample t-test. Anderson-Darling test is used, or the p-value of the Anderson-Darling test is appropriate to compare with the level of significance when the number of data points in your data are more than 2000. So just to summarize, if the number of data points are less than 2000, look at the p-value of the Shapiro-Wilk test. If the number of data points are greater than 2000, look at the p-value of the Anderson-Darling test. In both the cases, null hypothesis is that the data is from the normal distribution, and alternate hypothesis is that data is not from the normal distribution. Now similarly, if you are conducting a two sample t-test, we can carry out the hypothesis testing for checking the normality in the same way. Apart from this, we can also have a look on certain outputs which are given by JMP. For example, you can select an output under this fitted normal distribution, go to diagnostic plot and select QQ plot. It is basically a quantile plot, and here if your data is approximately normal or very close to the normal, then most of your data points should lie along this straight line. So this is another way in which you can find out whether your data is following normal distribution or not. If the data points are quite scattered, they are not around this particular black line, then the data is not following the normal distribution. So either you look at the p-value or you look at the quantile plot or the QQ plot for checking the normality of the data. Now I'm going to demonstrate what if you are going to conduct a two sample t-test and then you need to check whether the data is following normal distribution or not. For that purpose, I am going to select this data where I want to find out that if the mean distance covered by the gender 2 or gender 1, which are nothing but the coded values for male and female, they differ significantly or not. But to do so, to conduct the two sample t-test, what I need to essentially do is first of all check whether the data from both the groups, which is the group number 1 and the group number 2, it is are they normally distributed or not. To do so, again, you can go to analyze, you can go to the distribution, select distance as this particular role, and now drag gender to this particular field. So basically it is going to group the data as per the gender. Now click on OK, and here you will see that now you are getting two outputs. So this particular output is corresponding to the values which belong to the gender 1, and this output corresponds to the values which belong to gender 2. Now we can do the normality test on both the groups. So for example, for this particular group, go to this particular inverted right triangle, then choose continuous fit, fit normal. You'll see a report will be appended at the bottom, then choose goodness of fit here. So here again the number of data points are less than 2000 in this particular group. They are around 100. So we can actually look at the Shapiro-Wilk p-value. So p-value is not less than alpha. So we fail to reject the null hypothesis that the data is from the normal distribution. So this data particular group is good to go. Now let's look at the another group, the gender 2. So here again we can conduct the normality test. Click on this inverted right triangle, go to continuous fit. First of all, fit the normal distribution, and then you can, so the report will be appended at the bottom. Again, click on this inverted right triangle, and here choose goodness of fit. Here again we are going to look at the Shapiro-Wilk value, and as the p-value is not less than alpha, we fail to reject the null hypothesis and we say that the data is from the normal distribution. Here also, in both the scenarios, you can attempt to create a diagnostic plot or the QQ plot. If you see here, if you observe that most of the data points are near to this particular black line. So this is one of the indication that the data is following normal distribution in case you have QQ plot but not the goodness of fit test results. Similarly, we can do the same thing for the other group. We can go to this inverted right triangle, select diagnostic plot and QQ plot. Here also, if you will see that most of the data points, okay, they are near to this black line, the straight black line, and hence as we have concluded based on the p-value, we can say based on this quantile plot or the QQ plot that the data is following the normal distribution. So that is how you check the whether the data follows normal distribution or not in JMP, and it is pretty easy to do on the software. The normality assumption is and I won't say essential, but yeah, it's a good thing to have whenever you are conducting one sample t-test, whenever you are conducting two sample t-test, or the ANOVA, whether it is one way or two way. Apart from this, there are evidence in the literature which shows that even if the data size is quite large, or then the small departure from the normality can be tolerated by these tests. Basically, they are fairly robust to the departure from the normality. So if your data size is large, you can still go ahead with the two sample t-test, one sample t-test, or ANOVA, even if they are deviating from the normality a little bit. They are quite robust to that. So whenever you are going to conduct any hypothesis testing related to one sample t, two sample t, ANOVA, you must always first of all check whether your data is following normal distribution or not. If it doesn't follow the normal distribution, you can attempt uh, any non-parametric statistical test, or you can transform the data, make it normal, and then you can go ahead with the testing. So that's how you conduct a normality test in JMP.